In this video lecture, we'll try to understand state space analysis. The topic which is being covered in this video lecture is numerical based on obtaining transfer function from a given state model. Let us consider this example. Obtain the transfer function of the system represented in state space model as dx by dt equals, we have been given with the 2 cross 2 matrix having elements -5, -1, 3, -1 x of t plus 2, 5 u of t, 2 cross 1 matrix, y of t equals 1 cross 2 matrix having the elements 1, 2 x of t. So we already know the state space model of a linear time invariant system is given by the expression x dot or dx by dt equals ax plus bu, y equals cx plus du. So these equations, whatever we have got here, we will compare these two equations with the equation which is given in the problem. So if we compare these two equations, this equation and this equation, if we compare, in place of A matrix, we have these elements which is already given. In place of A, we have this matrix. So A matrix is -5, -1, 3, -1. Next, in place of B, we have been given with one more matrix, 2 cross 1 matrix, 2 rows and 1 column. Hence, B matrix is having the elements 2 and 5. Similarly, if we compare equation of y of t, these two equations, in place of C, we are having 1 cross 2 matrix, 1 row 2 columns matrix having the elements 1 and 2. So that forms C matrix. And finally, in place of D, we don't have any elements here, so it will be equal to 0. So D matrix is equal to 0. So these are the 4 matrices which we have obtained from the given state space model. We already know that the transfer function is given by the formula C into Si minus A inverse into B plus B. Si minus A, this I indicates identity matrix. So Si minus A inverse can be written as adjoint of Si minus A divided by determinant of Si minus A, where I is nothing but identity matrix. So this, to find out this transfer function, first we need to know what is Si minus A. So for that, we will be using this Si minus A equals, we already know that identity matrix, A matrix is 2 cross 2 matrix, which is already given. So identity matrix for 2 cross 2 matrix will be 1, 0, 0, 1. And to this identity matrix, we are multiplying with the term called as S. So this will give us S 0, 0, S minus A matrix is already, we already know what are the elements present in A matrix, -5, -1, 3, -1. So this corresponds to S minus of -5 is S plus 5, 0 minus of -1 is +1, 0 minus 3 is -3, S minus of -1 is S plus 1. So this is S minus A term, or S minus A matrix, Si minus A matrix. So after obtaining Si minus A matrix, we need to find out adjoint of it. To find adjoint of 2 cross 2 matrix, what we do is the diagonal elements will be interchanged. The diagonal elements will be interchanged, and we will change the sign of the other elements which are present in the matrix. That is the only thing which we do. So adjoint of Si minus A will be equal to, if we change or if we interchange the elements present in diagonal, S plus 1 comes here and S plus 5 goes there, and we'll be changing the signs of the other elements present in the matrix. So we had +1 here, so that becomes -1 here. We had -3 over here, so that becomes plus 3. So this is how we find out adjoint of a 2 cross 2 matrix. So after finding out adjoint of 2 cross 2 matrix, the next important thing which we have to find according to our formula is finding the determinant of Si minus A. So to find out that determinant of Si minus A is, this is Si minus A matrix, S plus 5 into S plus 1 minus 3 into 1. So when we simplify this, we'll get S square plus 6S plus 5 minus into minus S plus 3. So Si minus A will be equal to S square plus 6S plus 8. When we simplify this, we'll get the roots as S plus 2 into S plus 4. So this is the determinant of Si minus A which we have got. After this, we have to substitute all these things, whatever we have got in our formula. Transfer function is equal to C into adjoint of Si minus A into B divided by Si minus A. The reason why I have not written plus D here is because D is anyhow a null matrix 0. So we already know this formula for transfer function. C into adjoint of Si minus A into B divided by determinant of Si minus A, where B has the element 2 and 5, which is a 2 cross 1 matrix. C is having the elements 1 and 2, which is 1 cross 2 matrix. Adjoint of Si minus A we have already found out, and determinant of Si minus A also we have already found out previously. So we'll substitute all these things, whatever we have got in our transfer function equation to obtain the result. So transfer function will be equal to, in place of C, I'll be substituting as 1, 2, the elements which are present in C, 1, 2, into adjoint of Si minus A is S plus 1 minus 1, 3, S plus 5. In place of B, I'll be substituting as 2 cross 1 matrix having the elements 2 and 5 divided by Si minus A, determinant of that is S plus 2 into S plus 4. I'll be substituting that. Now, so if we clearly observe over here, we have a 1 cross 2 matrix is being multiplied with 2 cross 2 matrix. So when 1 cross 2 matrix is multiplied by 2 cross 2 matrix, the resultant which we obtain is 1 cross 2 matrix. So here we'll be getting a 1 cross 2 matrix. So 1 multiplied by S plus 1 will get S plus 1, plus 2 multiplied by 3 is 6 plus 6. Again, 1 multiplied by minus 1 is minus 1. 2 multiplied by S plus 5 is 2S plus 10. Multiplied by 2 and 5, the B matrix, whatever we have, I've written as it is, divided by S plus 2 into S plus 4. Next, after this, the resultant, whatever we get here is S plus 1 plus 6 is S plus 7. And 2S plus 10 minus 1 is 2S plus 9. So 2S plus 9 multiplied by B matrix divided by S plus 2 into S plus 4. Now, if we observe, again, we have got two matrices here. When 1 cross 2 matrix is multiplied by 2 cross 1 matrix, the resultant which we get will be 1 cross 1 matrix. S plus 7 into 2 is 2S plus 14 plus 2S plus 9 into 5 is 10S plus 45 divided by S plus 2 into S plus 4. So 2S plus 10S is 12S, 14 plus 45 is 59 divided by S plus 2 into S plus 4. So this is the overall transfer function for the given state model. I hope that you have understood this video lecture. Thank you.